going to look at Unit 2, Lesson 2, Reasoning, Arguments, and Proof, Part 2. Learning goals. Identify premises and conclusions in an argument. Okay, so we're just looking at those two pieces, premises and conclusions on some of them. And then also identify and develop syllogisms and other valid arguments. And we'll talk about those specifically when we come up on them. Okay, so back in 2.01, so you should have just watched that video. Okay, a proof is an argument. It's a set of statements called premises that are used to reach a conclusion. So, like if I take a look at this, grab my pen color. Okay, so this is a premise which is given to us. Okay, then another premise is like the body of it. Okay, so what we're talking about, and then it finally will reach a conclusion. Okay, so we have all these premises that lead up to a conclusion. So looking at this, it says identify the premise and conclusion in the mathematical proof. Okay, if a plane figure has 4 sides, then it is a quadrilateral. Okay, then from there, it's, just one second, let me get my color right. Okay, a trapezoid is a plane figure with 4 sides. Therefore, a trapezoid is a quadrilateral. Well, so given to us to begin with, that's a premise. Kind of the meaty body part that they're talking about, that's also a premise. And then what follows from that? A conclusion. Okay? It says identify the premise and conclusion of the mathematical proof. So this kind of goes along the way. So I'm going to read it all together and then I'm going to dissect it. So it says, if an animal is a gorilla, then it is stronger than an orangutan. If an animal is an orangutan, then it is stronger than a chimpanzee. Therefore, if an animal is a gorilla, then it is stronger than a chimpanzee. Okay, so we went all through these different steps. Okay, we'll talk more about specifically what this kind of step is in a minute. But for right now, we're just looking at the premise and the conclusion. Okay, so I have this first statement that's telling me that if it's a gorilla, it's stronger than an orangutan. Okay, so that's going to be a premise. Then I have my next statement. If an animal is an orangutan, it's stronger than a chimpanzee. Okay, so that's another premise. Okay, then lastly, therefore. So that's kind of like your key word, therefore. So I'm summing it all up. If the animal is a gorilla, so what we started with, then it's stronger than a chimpanzee. Okay, so like this is the guy that connected us. So therefore, this was like the way that we kind of wrapped it up. So that's what's called our conclusion. Okay. Okay, so valid or invalid. It says what makes an argument valid or true? An argument is true when the premises are all true, which then makes the conclusion to be true. So if you can, so like looking at this, if the first statement is true and the second statement is true and then the conclusion is true, the whole statement itself is true because everything's true on it. Okay, so you can kind of notice it on this one. So we've got the true premise at the beginning and then the true premise in the middle, and then we have a conclusion that is also true. Okay, then if you look at this one, it says, why is this not a valid argument? Okay, so if you notice, I've got a premise that is true, another premise that is true, but then I have a conclusion that is false. Okay, it says the conclusion is false because the statement of the 2 lines, then they intersect at the same point. Not if the 2 lines lie in the same plane, then they intersect. Line A, B, and C, D are in the same plane, but they do not intersect one another. Okay, if you look at these 2 lines, they're parallel lines. Okay? They do not intersect at all at any point. Okay? So you can say the first thing is true by itself, and then you can say, yes, these two things, they do lie in the same plane, but that doesn't mean that they have to intersect. So that the whole statement would be false. Okay, so now we're going to talk about the law of syllogism. So it's a logical argument that always contains two premises and a conclusion. Syllogisms have the following form: if A, then B; if B, then C; therefore, again, that conclusion word, therefore A, then C. Okay, so kind of like, let's kind of color code this a little bit. Okay, so look, I'm starting with if A, then B. If B, then C. Therefore, that key word, therefore, that gives me my conclusion. If A, then C. Okay? So it's like, and I'll kind of go through an example using words and not just letters. Okay, but what you can see is the two B's, they kind of connect. Okay, it's just like back there in that orangutan chimpanzee picture. Okay, so the B's kind of connect, so you can take the conclusion A and give it to C and have your conclusion. Okay, so let's look at this like in using words. It says fill in the blank to complete the statements. It says 12 cupcakes are a dozen. Okay, that's true. A dozen cupcakes are $5. I'm sure somewhere that's true. Therefore, if you buy 12 cupcakes, then you will pay how much? $5. Okay, that is the law of syllogism. Okay, let's look at it again. A rectangle is a parallelogram. True. The diagonals of a parallelogram are congruent. Also true. Therefore, a rectangle's diagonals are congruent. Okay, this last one I'm going to kind of line up a little bit different for you. Okay, I'm going to dissect the A then B. So a linear pair of angles are supplementary. Okay, so we've got, so this would kind of be like our A, then our B. Okay, then supplementary angles, that's what we're talking about again. So that's going to be our B as well. Okay, are 180 degrees. That's going to give me my C. Therefore, a linear pair, that's again talking back about A, R, and so it's like you need to wind up having two of everybody. So who do we have left? C, 180 degrees. Okay, hopefully maybe that make a little more sense. Okay, we have another law. So we have the law of syllogism, then we also have the law of detachment. Okay, so it just kind of states it a little bit different. So it's an argument that has two true premises and a valid conclusion. The premises and conclusion have the following form: if A, then B. A is true, therefore B. Okay, and we'll go through some examples of it too. So we're going to look at A. If A is true, that gives me A. Then you can state B. Then you just make the statement, A is true. I'm telling you, A is true. Then you come back to B has to exist. Okay, and we'll kind of show you this as an example. Okay, looking at this example, it says if a plane figure has four sides, then it is a quadrilateral. Okay, this is A. I'm saying if this is true, the next thing that you can say is B. Then I'm going to make another statement. This is A. A trapezoid is a plane figure with 4 sides. Okay, I'm making that statement. Therefore, if I'm making that statement, then I have to say that B is also true. Okay, so notice that this is not a valid argument. Okay, because it does not follow the law of detachment correctly. So I'm saying, okay, so I've got, this is A, arachnids. I'm talking about them. They have 8 legs. Spiders have 8 legs. That's true. Spiders are arachnids. Okay? It does not follow the order that it's supposed to. Okay? It's not supposed to be, it should say it this way. Okay? Arachnids have 8 legs. Spiders are arachnids. Therefore, spiders have 8 legs. That's how it should be. You can't put the end before the beginning in the law of detachment. Okay, so this is the way that it should be. Okay, conclusion. An argument is a series of statements that is made up of 2 or more premises and a conclusion. 2 premises and a conclusion. A valid argument is an argument in which a true conclusion is logically derived from a true premises. Valid arguments follow specific patterns such as the law of detachment and the law of syllogism. Okay, so we're going to have, during CC time, we'll be able to look into these two a lot more and have a lot of fun with them. All right, can't wait to see you Wednesday, guys.